I made an error in this last video, so I went back and erased it all the way up until I got to here. But I want to show you what happened briefly before I continue. So we got our final velocity here, or what we were looking for our word problem. And then I went ahead and plugged it into our kinetic energies to see if it was going to be the same. I already know that it's supposed to be our kinetic energy is not conserved here, and that our kinetic energy before should be greater than our kinetic energy after. So when I went to go do the math and it didn't work out, I had to stop and see where I went wrong, and it was right here. So I'm going to continue with this line. I'm just going to continue it down here so we can see what happened, or what the answer should be. So all right, we got a velocity of 24.9, and I definitely feel like this is gonna work out for our kinetic energy. Okay, so our hockey puck is moving pre-collision with a velocity of 24.9 meters per second to the right. All right, now we can take a look at if our energy is conserved. I did say already that it's not, but let's take a look at the math. The only reason, or the only way you can know for sure, is if we take a look at the math. So I don't know if it's going to be conserved or not. So we can set it up like this. So this is my total kinetic energy before. This is my total kinetic energy after. And I'll just plug in my variables. You have to make sure you're organized with your data, because there's so much variables here that are similar. All right, is this going to be the same as when we added these together? When we added these together, we got 0.92, and then our velocity that they're moving forward with is 4.2 squared. All right, let's see. I'm just going to round that to 52.8 joules. And let's see, this is pre-collision. Let's see what's going on post-collision. So pre-collision definitely is greater than post-collision. This is aligned with what I was expecting to see. It's always good to check your work.